Yeah, so you could have a public key registry. You could have a trusted directory service that stores a mapping from name to public key, and then you could trust this party. You can contact this party and ask them what is Bob's public key, and they would give you back Bob's public key. We'll see in a moment some details with making even that work so that you don't get the man in the middle when you talk to the directory service. But that's a great suggestion, yeah? Another suggestion? Yeah, so another mechanism that we'll learn about in class today are certificates. So some other entity can certify Bob's public key, and the way to certify it is using digital signatures we learned in class. So if you get a signature from that party that you trust saying Bob's public key is this, then that's one way to certify that you got the correct public key for Bob. Yeah. Any other ideas? All right. These were some great ideas. So let's explore them a little bit, because making them work, there are a bunch of details that have to, you have to get them right. Otherwise, this system itself could also be insecure. Okay, so the first one is a trusted directory. Trusted directory service. All right, so let's assume that there exists a party that everybody trusts. And there's issues with that. We'll discuss in a moment the drawbacks, but for now, let's assume that there exists this trusted directory that is able to map name to public key. So it has a table of name to public key. In particular, it has Bob's, public key, whatever the public key is. And when Alice wants to get Bob's public key, Alice can contact, again, the trusted party over the email and ask the trusted party, send me, public key of Bob. The trusted party looks up Bob in this table, and we can assume the trusted party is actually honest and is going to return the correct, is going to send back to Alice the correct public key for Bob. So what are some issues with this approach? Or what are things we have to be careful when we actually implement this approach? Yeah? Exactly. You can have a man in the middle here as well. So even though the trusted directory wants to return Bob's public key, the attacker is going to return, the public key of the attacker. Okay, so the question is, all right, so how could we possibly protect against this man in the middle between the trusted directory and Alice? Yeah, so here's a suggestion, and let's try to understand. Let's see if it's good. I'm going to have it in a different color. So basically, the suggestion is that Alice is also going to send her public key along with the request for Bob's public key. So then the trusted directory responds with the public key on top of Bob's public key. That was the suggestion. Yeah, okay. Any ideas? Is this protecting against the attack? Any ideas? Yeah? Yeah, exactly. I mean, it's a great idea that you want to somehow tie it to Alice, but again, the problem remains because the man in the middle can keep Alice's public key, but it will replace the public key of Bob with the public key of the man in the middle. Okay? So this problem still remains. Okay, so this was a good straw man to think about. Right? Any other ideas? Yes? Yeah, that's a great suggestion. The suggestion is Alice is going to purchase some service from the trusted directory. Initially, when she purchases this service, somehow they can exchange a symmetric key. And then what can you do to this public key of Bob to make sure it's coming from the trusted directory? What can you do with it using this symmetric key? Can someone raise their hand? Yeah? Yeah, you can mark it. So not signing, because this is symmetric key, but you can mark it. Okay, so you can attach the MAC with the key of the public key of Bob, and then Alice does know this is coming from the trusted directory. That sounds good. So that's a great approach. Just to make it simpler, I'm going to instead just use a public key. I'm going to use a digital signature instead. And why? It's because I imagine that Alice, for example, in her browser, she already has hard-coded the public key of the trusted directory, but you don't want to hard-code the symmetric key of the trusted directory because that would be hard-coded in everybody's browser, so everybody would know it, so then even the attacker would know it. So instead, let's use a public key scheme instead. So I'm going to use, so the public key of the trusted directory, assume it's hard-coded. I know, maybe in Alice's browser, and she uses her browser to, talk to the trusted directories. In any case, it's hard-coded in Alice's device somewhere. Okay, so she knows for sure what's the public key of the trusted directory. She knows the correct public key of the trusted directory. Because again, if she were to have to ask for it to the trusted directory, there would be a man in the middle on that, right? So let's assume that instead she has it hard-coded when she downloaded her browser or got her device. For example, that's the case with Verisign, which are such entities that serve, to help with public key distribution. We have their public keys hard-coded in our browser. So similarly, assume that's the case here. So what the trusted directory is going to do is it's going to also append a signature using the secret key of the trusted directory on the public key of Bob, okay? And Alice can verify the signature using the public key of the trusted directory and indeed make sure that this message is coming from the trusted directory. But even this is not enough. There's still things that the man-in-the-middle attacker can do. Exactly. So you cannot, the man-in-the-middle can also be someone who is in this directory with their own, bad public key, compromised public key. And the man-in-the-middle can say, hey, directory, can you please give me, the public key of man-in-the-middle? And the directory is going to give him back this signature with the secret key of the trusted directory for the public key of the man-in-the-middle. Okay, so then the attacker can simply take this signature. Oops. Sorry about that. So it's going to sign it with the secret key of the trusted directory. And the attacker can simply take this signature, right, and put it instead of the signature on Bob's public key, and again do the same trouble. Yes, absolutely, yes. That's a possibility. So Alice can add a nonce to, what is it here? So Alice can add a nonce, and then this nonce could be included in the signature. Now, let's think a little bit whether this is fixing the problem. Exactly. So the man in the middle can take the nonce, they can look at the nonce, and then they are going to send it to the trusted directory saying, with this nonce, give me, the man in the middle public key. Okay, and then the trusted directory is going to reply with the signature on the nonce and the man in the middle public key. And Alice is going to be happy when she shouldn't. Okay? So we'll see the nonce will help us with other things. It's still a great suggestion, but we still need something else here. Yeah, that's the answer, exactly. So when TD is answering, he says, public key is Bob's key. So it doesn't just sign the public key, it signs a message, a text, a string saying this is Bob's public key. Okay? So now when you look at this signature, it's completely unambiguous, the fact that it belongs to Bob. Okay? The trusted directory would never sign the public key of the man in the middle saying it's Bob's. No, it's just going to sign the public key for Bob saying it's Bob's. Okay, so the whole idea is that you want the signatures to contain statements that are really not ambiguous. And in general, when you design security protocols, you really want to make your signature content as explicit as possible to really describe the situation so that the attacker cannot reuse that signature for different purposes. Okay, so really make the content as explicit as you can. Okay, so now if the man in the middle is going to ask for his public key from the trusted party, this is what the response is going to be. And if he tries to send this response to Alice, Alice is going to be, okay, but you give me back the public key of the man in the middle. I'm not okay with that. I wanted Bob's public key. Yes, absolutely. That's a very, very good question. So we are assuming unique identifiers here, right? We assume unique identifiers here. And that's a good question. You can think, what are they tied to? Could be tied to domain names, could be tied to emails. That's a whole other discussion. But for now, assume that everybody has a unique identifier. That's a good question.